Yeah, a couple more minutes. Um, Basically, for this workshop, I'll be using, yeah, my face. I'll be using a Raspberry Pi like this, connected with a Pi camera, pretty much. And the whole the whole thing for this workshop is being able to do real-time computer vision and object recognition with an embedded device like the Raspberry Pi. So you could run tools that are already known, like normal TensorFlow or OpenCV to get this, but usually the performance that you get from it is really bad. So Google basically came up with a light version to their own TensorFlow API, and it's basically made to be run from Android devices to iOS to even Linux embedded devices like the Raspberry Pi. Um, and it's pretty cool. Basically, what it does is instead of using, because the way that computer vision works, it's machine learning. So you have a neural network. Um, Instead of using 32-bit float values for each neuron, it changes it so you can use 8-bit integer values. Um, by doing this simple change in the data type that you're using in the neural network, you're basically increasing performance by 4 times. You're not really losing that much accuracy at the end of the day. So even though this solution is great for embedded devices because it allows you to have more frames while you're doing it in real time, you could even use it for your own computer or whatever if you want to get even more performance. So I'm gonna get started more or less with a workshop. Hey, Woody, you just joined. So this workshop is not gonna be that in depth. I'm just gonna be going over how to set up TensorFlow with the Raspberry Pi, specifically TensorFlow Lite. Um, we're gonna be using a model that Google provided to us. It has basically 80 different objects that it can recognize. Some of them we know, for example, a person, a car, a keyboard, bottles, whatever. We're gonna basically see how that works and how we set it up. If you guys like the workshop, I can create a second part where we're gonna be creating our own models, and maybe we can implement that project into our robotics, into a simple robot, you know? But yeah, actually, well, for the person that just joined, we're using a Raspberry Pi with a Pi camera. I'm gonna be streaming the screen to my desktop using a remote desktop, so you guys can see everything that I do. 1 second though. Let me start sharing. Okay, I hope you guys can see my screen now. So yeah, actually for this workshop, I basically used this GitHub tutorial, and it's pretty cool. He got the Raspberry Pi to work with the TensorFlow Lite, but not only that, but he also implemented this thing right here, which is well, it's called a Google Coral TPU unit. What it does, and you can see it here happening, it's basically like an embedded device that is specialized to do machine learning. It's very low power and it works great with the Pi. You basically connect it through USB, and I was able to get like regular TensorFlow Lite, sorry, if you run regular TensorFlow on the Raspberry Pi 4 and you're doing it in real time, I was able to get like 1 FPS in real time. If I changed to TensorFlow Lite, I was able to get 4 times that, like around 4 to 5 FPS. And finally, by adding this device into my Pi, I was able to get actually 25 FPS in real time. And that's pretty great when, this is such a small computer, the Raspberry Pi. By just adding this through the USB, you're able to get performance that is kind of comparable to what you get with a real laptop, instead you're doing it with a Pi and a TPU unit. So for this workshop, I'll first set it up with the TensorFlow Lite and we're gonna see the performance and we're gonna see how it recognizes objects. And finally, I'm gonna add this element into it and we're gonna see the better performance. If you're interested in getting this exact configuration working in your future project, I'll give you the name and where to buy this. It's around $50 though, so it's an investment. You're gonna have to need it. You're only gonna use it if you need really fast computer vision from your Raspberry Pi, from a really compact embedded device. But trust me, um, for most projects, having 4 to 5 FPS can be really good enough. You're only needing like faster recognition whenever you're doing stuff that needs faster responses from the Pi. But yeah, before I just keep talking, I'm just gonna get into it. So I'm gonna connect to the Pi through a remote connection. Just 1 second. And here it is. This is basically my desktop for my Pi. I hope you guys can see it. Let me pull out just in case, the chat, in case someone has any questions. Wait. Oh, here it is. Never mind.
Can you post the link to the GitHub?
Yeah, I actually will. I don't know if any of you guys have right now in your possession a Raspberry Pi and want to follow this. If not, you can always, if you get it after, you can always see the video, and I will be sending you the GitHub. Let me post it right now in the comments. Yeah, just 1 second, because I'm doing everything with one screen. And it's actually like he actually created it's a couple GitHubs, but this is like the main one. That is just to get the Pi to work with TensorFlow Lite. This is using Raspbian. Then inside of there, you can see that he has another one where he's basically teaching you how to train the models. And what's changing really, this is no different than training models for normal TensorFlow. The only difference is you're creating quantized versions of the models. What does that mean? Well, those are models that instead of using 32-bit float values, they use 8-bit integer values for each neuron. And just having that change basically multiplies performance by 4 times, at least in my Raspberry Pi. So yeah, it's not any different than creating models for a normal TensorFlow application. You're just having that extra step of converting it to be compatible with TensorFlow Lite. That's all shown in that GitHub. And if you guys like the workshop, maybe I can have a second part where I create a model in the workshop and we make it work in a project. But yeah, so yeah, let's get into it. I'm actually gonna also have that running here. GitHub. Yeah, 1 second. Yeah, that's basically what's happening here. Again, sorry, 1 second, guys. So, well, before getting started into that, I want to show you guys basically the options that TensorFlow Lite allows us to have. Since this is like, as you know, a cut down version of the regular TensorFlow, you cannot do all the tasks that you can do with regular TensorFlow, but these are the things that you're allowed to do. You can do image classification, object detection, post estimation. You can generate replies to texts, segmentation, and I'm gonna show you more or less each one of these. So image classification, which is one of them, is just you basically give the TensorFlow model, you give it an image, and it's gonna tell you what it thinks that image is. For example, here you give it a dog image, and it returns just a probability of what it thinks it is. This is pretty simple, and something that is similar, but in my opinion is better and more useful, and that's what we're gonna focus this workshop on, is object detection. Where basically you're giving it an image and the model is going to be able to recognize objects in that image. The difference from this to the previous one that I showed you is this time the model is going to return the name of what it thinks it saw. It's going to return a score, which is how certain it is that what it saw, it's that. And finally, allocation. And this is key. The location basically is like the distance in pixels, I think, from each one of the corners, left, top, right, down. Sorry, top, left, bottom, right. Yeah, and it's basically like the distance in pixels to each one of the corners of the image. Whenever you see these examples that they have like a square with a tag and everything, TensorFlow is not really the one returning you an image with that. TensorFlow only returns this right here, the class with the score and the location. You have to then by yourself, if you decide that you want to have this, then you basically take these values and then you can draw a square around the object and maybe put the tag. This is done because not in every case you're gonna wanna have something like this. Maybe you wanna just have the program running, the model running, and you wanna use the location to, for example, tell your robotic arm to move to that location. So you could basically skip having to draw a square and having to do the tags and everything, and you could just use this straight up into your robotic arm code. So yeah, since in this workshop though, I want to use, I want to draw a square in my objects, I'm going to be using that. And we're actually going to use OpenCV to draw the square in the image. But the whole processing and image recognition is being done by TensorFlow. So yeah, I went kind of in a tangent there, but this is object detection. Most of us already know it. It also allows you to do pose detection, and this is pretty cool. Sorry, pose estimation. you can see how here in an example, it's a lady and she's moving around, and TensorFlow is basically connecting the limbs as they move. This is probably the technology that is used in like the Kinect and all of those devices where you kind of like are able to dance and and like you move in the game, for example. Segmentation is a little different, and it's basically separating an image into the elements that basically take part of it. This is one of the examples of segmentation, like separating the background from the persons. And machine learning like this is used in apps like Photoshop, where you have like smart choices. You know, you click like a person or whatever, and Photoshop by itself just takes away the background and it just selects the person. It probably uses a segmentation model like this one. I haven't been able to play with this, but this also looks really cool. Style transfer. Just imagine like you can give an image and then you can paste the style in it. Again, all of these examples they give you, they actually have working examples that you can see on the GitHub if you want to work on it on your own. It's pretty cool stuff. But yeah. So yeah, let's get started here. Well, one second. Let me get this here. Yeah, I'm kind of all over the place. The first thing that I'm gonna do is just get the, whoop, I guess not. I guess not. Let's reconnect. Yeah, since I'm basically using, I'm not directly having the Pi connected to the screen, I'm doing it through a remote desktop. It may not be very stable. So I just rebooted it and let's wait a couple seconds. And this workshop is being done on Raspbian, but I'm actually later on this week, if I have any time, I'm actually gonna get it to work with Ubuntu, which can be more useful for other projects that use tools that work explicitly in Ubuntu. So if you're interested in that, I'll be on the Discord and you can ask me. Okay, let's see if we can connect now. Oh, we can. Okay, that's pretty great. So before doing anything, I wanna make sure my Pi has all the libraries up to date. So Pi get update, sorry. Oh my God, sudo apt update. And I hope you guys are able to read what it says. I hope it's not too small. You also do sudo apt upgrade. Yeah, since I already did it beforehand, I don't really have to. But if this is your first time doing it, it can take up to an hour. Once you do that, then you want to make sure, and this is something cool with Raspbian, you have an option like Pi configuration. And you can actually see the interfaces, and you can, because by default, the camera and SSH, in this case that I'm using to communicate, are disabled. You can enable them this way. If you don't do that, your camera is not gonna work. at least if you use the Pi camera like this. So that's pretty important. After that, we get started, and I'm gonna clone the library that comes from the tutorial. That's gonna be really useful for this. I could type it all, but since I have it here, it's easier for me just to get it. Yeah, it's gonna take some time. What I'm thinking is while we get that downloading, let's just get started like seeing the library and more or less what's gonna be happening. So, oh well, that's done. Never mind. Well, what we downloaded right now is just basically a library that's gonna have a bash script that's gonna have all the things that we need to download to get this working, and it's gonna have a couple Python files that are already pre-written that are made to take the video from the Pi, and they basically already do all the TensorFlow stuff. So we just get it working. I'm gonna then go into those files and we're gonna see more or less what's happening and how you could take this as your base to work on for whatever project you need to do. There's no point into creating all this by yourself when it's already provided. You just need to implement, already working things to fit your use case. So basically now I downloaded that file, and now I want to change the name that it has. It's called TensorFlow whatever. I just press T and then tab and it filled it up, and then I'm just gonna rename it to TF Lite 1. Now if I press LS, we can see all the directories that the Pi has, and one of them is the one that I just renamed. So I want to change directory into it, and now we're inside. One thing is, since, and he says it right here, it's recommended to create a virtual environment to run this, since Python gets updated and it may create conflicts. And whenever you create a virtual environment, you avoid many of these problems. So yeah, let's just get like sudo pip3 install virtual env. Hope it doesn't take that long. There it is. Now, yeah, I'm basically just following, but this is basically essential to get it working. And if you guys are interested, then we can create more stuff with this workshop later on. Let's see now, inside our file, we have a TF Lite folder. And to actually get it started, like the virtual environment, you do source, then you type the folder that it's in, TF Lite 1 env. And you can see that we successfully started the virtual environment, since we have this in parentheses. Now, before just going there, I want to show you guys exactly what we got from that GitHub repository. So we're here. And this is the file that we got from the repository. And we have a couple things. First, we have actually a bash script. And this is what we're going to do now to install the dependencies for TensorFlow Lite and OpenCV. Basically, this script is going to run these commands for us right now. All this stuff is for OpenCV. Then we need also Python for OpenCV. And finally, we need to install TensorFlow. And actually, the version of TensorFlow changes depending on which version of Python you have. So if you have 3.7, it downloads this one. And if you have 3.5, this one. You know, this script is really cool because it does it all for you. But if you go to the TensorFlow website, you could see that, you know, the steps to install it is basically this. With the added bonus that we're using OpenCV here, just so we can draw the squares in the objects. You could totally do this without using OpenCV, but it just creates the visual feedback that we like, you know, having an image and we can see what's being recognized. If you're just using TensorFlow for like to know the location of the object, you don't really need to have OpenCV. So yeah, let's just keep going. Well, before that, um, hmm. How do I do this? Well, doesn't matter. That's not the only thing that we have here. Actually, we also have a test image and a test video. Because TensorFlow, you can use it, well, we're going to use it in real time right now, but you can also use it giving it images or videos. And he actually created a script for each one of those. One of them for image, for stream, for video, and for webcam. For example, let's open the image one and let's see more or less what's happening. And if you go here, you're basically seeing like he's importing all the OpenCV stuff and the Pi is already lagging. I hope it doesn't crash it again. And I think it did. Oh well. Yeah, it did. In my defense, this is my first time using a remote desktop because I wanted to be able to show it to you guys. I hope that's not a problem, but I'm gonna basically reboot it every time it crashes. Ideally, you wouldn't be using remote desktop for your own solution, so you wouldn't run into this problem. I wonder why it's happening though. But yeah, let's just give it a couple of more seconds and we should be good to go. There we are. I didn't think about it, but it's gonna get really dark and that's gonna make the object recognition harder. So that's a thing. Yeah, right now I just put out the command line. You guys remember that we need to open the virtual environment, and since we logged out, let's do it again. I'm gonna change directory to tflite1 again, and then source tflite1 emb bin activate, I think it was. Yeah, that was it. So now that we're inside the virtual environment, I'm gonna go ahead and install all the dependencies. So just do bash get pi requirements. .sh. Yeah, so this download is actually long, I think. So while that's going, I'm gonna go back to what I was showing you guys. For example, like looking at this one. So if you see here, we're importing the CV, then we have the arguments that we're giving the command line. Those arguments are, for example, the folder that the file is located in, labels, the image, the directory. Then you're giving names to those arguments so it can be used here. Some correction whenever you input something that is not what it expected. This is basically all, like 90% of this code you can basically reuse for your own uses. Here we're basically importing all the TensorFlow libraries. Yeah, grabbing the images, defining the paths for them. Well, if you use the TPU, which is this device right here, this is also importing the libraries for that. What I think is most interesting and important is right here. You have these three variables: boxes, classes, and scores. This is using the TensorFlow model and library to return the values. And these are the values that I showed you before. These three variables are gonna be giving you back one of them is gonna be just an array with the classes. The other one is gonna be an array with the accuracy, and one of them is gonna be an array like 2D array, double dimensional array with the locations. So yeah, boxes is the one that has the coordinates. The other one is the names, and then the confidence. And basically here inside of this is happening in a loop. Here we're basically defining the bounding boxes, and then you're creating the rectangle in the face or the object, and then you're creating the label and doing all that, and at the end you show the image with OpenCV. So yeah, I don't want to get too into this, but for example, if you want to, you run this code and I want to know the location of my object so I can do logic with that, for example, implement it into my arm or whatever. Well, I know that I will have to go to the boxes variable and retrieve that from there. You also know that if you want to know exactly what object is what, then you use the classes one, which is getting the index. For example, and I don't think we can see that right now because we haven't downloaded the model, but once we get the model, you're gonna see that you can actually see all the objects that it can recognize. We're gonna use some of those into the end. Yeah, let's just keep going. I don't wanna get too lost into the details. So we got all the dependencies to work. Now we just need to download the model. And this is a model that Google provides us with. It's called the Quantized SSD Lite MobileNet V2. What does that all mean? Well, quantized, and I already told you guys, means that it uses Quantized means that it uses 8-bit integer values instead of 32-bit floats, which is the whole point of using TensorFlow Lite. SSD Lite is just showing us that this is a library just made for TensorFlow Lite. Mobile, again, mobile devices. And version 2 is probably because there was a version 1. This is trained using the MS Coco dataset, which is very popular, and it has a lot more. Well, if you search it online, you can actually download that dataset and train your own models using it. But Google already provides you with this one, which may be enough for what you want. This library recognizes cars, it recognizes persons, recognizes bottles, keywords, a lot of stuff. I mean, if if what you want to recognize is in this library, you don't even need to model anything. You can just grab it and use it pretty much. Sorry, I'm getting a message. Okay. Let's just go ahead and download it. I'm just basically grabbing the link from the GitHub. If you go to the link, you're gonna see it's basically like a, yeah. Here, yeah, you can get it from here. And we downloaded it, and it's funny because the whole model is just 2 megabytes. So yeah, that's pretty light. Then we need to unzip it. I'm just gonna type Coco, then tab, and the whole thing appears. And then we're gonna put a new name. You do that using the D flag. Then the name that I'm gonna give it is sample DF Lite model. You can change this to whatever you want. But yeah, now if we go back to the file, you're gonna see that now we have here our sample DF Lite model. And you have this is pretty interesting because, you know, this is the model DF Lite. This is what you give to TensorFlow. But the label map can be used to basically let you know what objects this model can recognize. You can recognize persons, bicycles, cars, motorcycles, airplanes. I think in total is 80 objects. Toilet, laptop, mouse. So yeah, again, maybe I'm gonna have a bad time because it's already getting dark. Let me get the light. Never mind. I don't. I think my light bulb may have burned. So maybe it's better if I hurry up and we get this to work before it's night. But yeah, let me just keep going then. We just unzipped it. Oof. He shows you the steps that you will need to take if you use your own model. We're not gonna do that right now, but we may in the future if you guys are interested. Now he also mentions about, oh, never mind, let's just run it. Python 3 DF Lite protection webcam.py. Then model directory equals sample DF Lite model. Let's see what happens. We get a stream of the camera. And for example, here you can see my face and it's working. As you can see, this is running at 5 to 6 FPS. If you try to run this without TensorFlow Lite, you will be getting 2 FPS at most. And this may not seem like a great change, but it changes from being like barely usable presentation slide kind of thing to almost having like, you know, if I move and stuff, it's working. But we can actually improve this a lot if we end up implementing this, which I will in a little bit. But this is just to show you guys that if you have a Raspberry Pi and a Pi camera, just with that, you can get a model to work in real time with around 5 to 6 FPS, which is enough for most cases, in my opinion. Let me get it to work with other stuff. For example, I have a keyword here. Will it detect the keyword? And it does. It detects the bottles. Does it detect my laptop? Yeah. It actually detects it as a TV right now. Maybe if it had the whole thing. So yeah, it detects a lot of things. The way that you avoid it taking false detections is by being more constrained. For example, like right now, I'm not having a lot of, like, it can detect anything that has, I think, more than 40% certainty. If you push that higher to, for example, 80%, then it's only gonna detect things that is really sure they are. I'm gonna move my mouse here and let's see if it detects it. And it does. If you had better lighting, this will work better too. As you can see, this is pretty dark. I'm gonna put a bottle here. And there it is. And this is a keyword and it's detecting it. So yeah, we got it working. For now, I'm gonna stop it. You can stop OpenCV. Well, let me go here. You can stop OpenCV Windows by pressing Q. So yeah, just doing that, it worked. Now what I'm gonna do, and I'm just gonna focus on adding this module so we can get better performance and see how that ends up working with us here. So here in the GitHub, he mentions it. Basically, this device is made by Google. It's a tensor processing unit. It's designed for highly parallelized tasks. Usually, when you're working with a desktop PC, whenever you want to do any type of machine learning, you would use your GPU to do those tasks. That's great because GPUs like this processor right here that I have, they work with basically parallelized tasks. You know, they do many tasks at the same time instead of like a normal processor that it does one task at a time. This is great for machine learning. However, you're not really gonna put a GPU into a Raspberry Pi, like a sizable one. That takes too much energy and that takes too much space. There's something similar though that it's already sold, and it's the Jetson Nano, and it actually has a GPU in it, and it's pretty cool. However, you can get better performance with a Raspberry Pi and using this. Way better performance actually than a Jetson Nano, because this is specifically designed just for machine learning. It's really low power and it works over USB. I don't know what to say. I think it's kind of like magic, and we're gonna see it right now. Also, well, never mind. Let's just keep going. So yeah, here is telling us to go to the virtual environment. We're already there, as we see here. Yeah, so This, of course, this element needs a package to work. This is basically the command that you use for that. So I'm just gonna get it here. And there it is, it's installed. Let me do it again just in case, because I don't think I got it right. Yeah, and then sudo get update. Okay, that's perfect. Then we have another library. And then again, this is just to get it to work. This is nothing special. If you go to the own TensorFlow website, you're gonna see basically the same steps. And you need to do them regardless of whatever device you have. You can use this into any device, any computer, but it's especially useful for embedded devices that don't have a lot of performance, because you take away all that work from the CPU and you send it to the TPU, the tensor processing unit. So not only does it allow you to have better performance with your Pi, but it also frees up processing power, since it's not working so hard just to get the 5 or 6 frames. If you wanted to use this for a robotics project, then you could have computer vision working in the background being processed mostly by this, and then you could have free CPU space to process other tasks that are also relevant, because not everything in a robotics project, for example, is computer vision. You have other things going on, sensors, you have, for example, or LiDAR and stuff. So then again, it's great because it's going to allow us to have a Raspberry Pi for our project at least. If you're interested, again, I'm going to be playing with this on Discord over the week. Just hit me up and we can go on a call and work on it together. That's completely fine. Yeah, so actually, and this is pretty interesting, you have two different libraries that you can use. One is the standard and the other one is the max. And you can get better performance using the max, but then this can overheat. So, it's your choice. I'm gonna use the standard. And then to use this, which is a TPU processing unit, sadly, you need to use a special library for it. The only thing that you would need when you're training the libraries, you create the library and you train it as you would for a TensorFlow Lite. And then you use, and Google already provides this, it's just like a converter that allows you to convert it into a TPU compatible model. But we don't really need to do that since we're just using an example model. I'm just gonna get it here. Again, if you're interested into how to create your own models, maybe we can do a workshop on that. That would be pretty interesting in my opinion. But yeah, I don't know. We downloaded it and now we just want to change the name. The MB command, and let me do it manually so you guys can see. MB technically stands for move, and you use that command to move files from one side to another. But you can also use it to just change the name, like you're moving it into the same directory and you're just changing the name. And I'm gonna do that. So mobile, and then the other thing here is sample TF Lite model, then H TPU file, and that should be enough. So let's run it. Paste. Ooh, we have an error. I must have done something wrong. Let me see. Let me go back and redo the steps because I probably missed something. Paste. I mean, it was working yesterday. Copy, paste. That's great. Then, oh, I know what it is. I forgot to connect my TPU. So all you need to do, and the only advantage of having a Raspberry Pi 4 is that it has, let me see if I can show you, USB 3. And that actually helps a lot because this is basically bottlenecked by the bandwidth of the USB connection. So having a Raspberry Pi 4 for this case is gonna allow you to have more performance. So I connected it and it should work now, I hope. But let's see. Let's see what happens. There it is. And we're having around 23 to 25 FPS. And this is a person. It's really dark, but it's still recognizing stuff. I mean that, yeah, that's pretty dark. A bottle. If you have, of course, if you have better lighting, it's gonna work better. This is the keyboard. Yeah, the laptop. It's not working great because it's pretty late. But you guys see the idea. We were able to get real-time computer vision via Raspberry Pi at 25 FPS, which is pretty great in my opinion. Using TensorFlow Lite and a TPU. Sorry, an external TPU here. External TPU device. And I think that's it for now. I don't have any other things to present to you guys. But if you'd like the workshop, and I'm gonna be working on this anyways for the robotics project, I can definitely have a part 2 where I create with you guys, we create our own model. We train our own model and we use it for a simple project. I think that could be a cool workshop. I don't know what you guys think. But yeah, I think, yeah, I have to press Q to end it. And I think that's it for now. I hope you guys liked it. If you have any questions, just let me know. I did a bad job. I didn't look at the questions. I don't think there's any, but still.
Thanks, Miguel.
No worries. I hope it was interesting. This is more just to show you a possibility that you can use for the future. Yeah, if you need to use computer vision, this is an option. A pretty good one in my opinion. So yeah, I don't want to take much more of your guys' time. So see ya later.